Hi, this is Ali and you are watching fourth video in series How Internet is Secured. In previous video, we looked at definition of authentication and authentication factors. This video is about evolution of authentication technologies, from very basic in-house techniques to OpenID Connect. We'll start with how authentication was done in early days of Internet, problem of excessive access leading to rise of authentication services. We'll cover some useful definitions which will be handy for later concepts. Then we'll cover what OpenID Connect and OAuth are, and then a detailed overview of OpenID Connect. In early days of Internet, when need for protected content like emails emerged, the solution was usually the humble sign up and login forms. Two input fields, a few other data fields, and a submit button. That's it, and you have a way of registering and logging in users on your website. Store the provided values away in a user's table in your database, match them in the next session during login, and you're done. Next time user would see a hello followed by his name when he logs in. Personalized user experience has been achieved, and believe me, it was a big deal back then. Your boss must be so happy he might give you a bonus. But what if someone is able to access your users table, which in most cases was also named users? The attacker would be able to see usernames, emails, passwords, info for all users on the website, and potentially other websites as well, since most users use the same combo everywhere. You investigate and come across something called hashing that encodes the passwords into a pseudo unreadable format. You don't need to know the password. You just need to match it with the one being provided by user in next session. Hash to hash password comparison fixed the issue. Again, your management is proud of you and may give you an awesome increment. Then someone who was casually scrolling the users table noticed something. There were a ton of duplicate encoded passwords in database. Is encoding broken? You investigate again to find out most users use the same easy to remember passwords like hello 123 my password, etc. If an attacker encodes them using the same public encoding algorithm that you're using, most passwords in your database are as readable to attacker as plain text. Again, you investigate and find out a technique called sorting, which adds random characters to passwords before hashing. The users table is now secure. But is it? Did you forget that users were still sending passwords over plain HTML visible to any skilled person trying to intercept? As developers those days hadn't watched part 2 of the series about HTTPS. We haven't even scratched the surface of exploitable vulnerabilities yet. So no, there was not going to be a that's it. As developers got smarter, so did the attackers. Every day a new technique, a new challenge appeared. Expecting web developers to keep up with daily developments was simply too much as they had much to learn in their own field, and not to forget an actual business website to attend to. A new class of developers dedicated to security came up, but not all companies could afford such an overhead. But they could not ignore the security aspect either, as the breach is costly both in terms of revenue and public view. What started as a simple two-input form turned into a nightmare for most developers and site owners. Managing sensitive user data was serious business, and not everyone is at the same level of understanding on how to handle it. While people were struggling with user passwords and authentication, the rise of mobile apps and social media brought in another challenge, the challenge of unrestricted access. Let's understand with an example. Say you came across a nice personal finance manager app which helps you log daily spending and stores them securely in Google Drive. The app asks you to provide your Google credentials so it can access your Google Drive and save your spending history in the cloud. Few days later, you get to hear from your friends that they are getting emails from you regarding exciting opportunities to make money. You have no clue, of course, but you eventually figure out from searching on internet that the application you entrusted your spending info with is not only selling your spending info in black market, it also has full access to your contacts synced with Google and control of your emails too, being used to send scam or spam emails to your contacts. Pretty much full access to all Google services available to you since sharing your Google credentials meant unrestricted access everywhere. That was a serious problem. You had assumed that the app would access Google Drive only, but it was able to access pretty much everything. This is just one hypothetical example, but lots of apps on social media platforms and mobile phones were doing exactly similar stuff, going beyond mandate and doing stuff you didn't even know could be done. If you're not the consumer but the provider of API services being exploited, you are now looking for a way to restrict access of third-party apps to legitimate authorized purpose only. The authentication and authorization nightmares discussed earlier were simply too much for most organizations to tackle in-house. Large corporations with big resources tried to come up with solutions of their own, but result usually was proprietary solutions which needed to be learned by app developers individually. It was this ecosystem of connected apps that ultimately led to standardization of best practices and interoperability, and eventually gave way to rise of open standards like OpenID Connect for authentication and Open Authorization or OAuth, followed by OAuth2 for authorization workflows. Before jumping to OpenID Connect, let's go over some prerequisite definitions and then details. It's okay if they are a mouthful up front, as I would be using proper definitions here, but they would be explained with examples later on and everything would make sense. Right, federated identity. Federated identity allows authorized users to access multiple applications and domains using a single user verification system. It is closely related to single sign-on, but it is meant to allow access to resources beyond a single domain or organization. Identity provider, abbreviated as IDP, is a system entity that creates, maintains, and manages identity information for principals and also provides authentication services to relying applications within a federation or distributed network. Identity providers offer user authentication as a service. Relying party applications, such as web applications or apps, outsource their user authentication step to a trusted identity provider. Such a relying party application or client is said to be federated. That is, it consumes federated identity. Right, the third definition is resource owner, an entity capable of authorizing access to a protected resource. Users allowing access of API provider resources to apps act as resource owners. In the previous example, you were the resource owner authorizing the client to use Google Drive. Too much technical jargon in one slide, right? Don't worry, you don't need to memorize those. Just glance over and with repeated usage and examples in next slides, they would make much more sense. OpenID Connect is an open standard and decentralized authentication protocol. It allows users to be authenticated by cooperating sites known as relying parties using a third-party identity provider service, thus eliminating the need for websites to provide their own ad hoc login systems and allowing users to log into multiple unrelated websites without having to have a separate identity and password for each. Users now create accounts by selecting an OpenID identity provider and then use those accounts to sign in to any website that accepts OpenID authentication. OAuth, and do note that we restrict our discussions to incompatible OAuth2 version, is an open standard for access delegation, commonly used as a way for internet users to grant websites or applications access to their information on other websites, but without giving them the passwords. OIDC is built on top of OAuth2. In the domain model associated with OpenID Connect, an IDP is a special type of OAuth2 authorization server. Enough definitions to digest? Well, sadly, there would be more to come. But let's see what OIDC is first, since this video is mostly about authentication. We'll explore OAuth2 in a later video. As briefly described in definitions earlier, OpenID Connect allows a user to use a single set of credentials to authenticate with multiple websites or apps. If you have ever seen a sign up or sign in page where a bunch of social buttons are listed titled login with, say, login with Facebook, Twitter, Google, you have seen OIDC being used. When a user visits a website that supports OpenID authentication, the website will redirect the user to their chosen OpenID provider or identity provider, abbreviated as IDP. We'll use the abbreviation IDP going forward only. The IDP will then prompt the user to authenticate themselves, for example, by entering a username and password. Once the user is authenticated, the IDP will generate something called an identity token and send it back to the website. The website can use this identity token to authenticate the user without needing to know their actual credentials. What a relief. If you own that website we are referring to, the nightmare is finally over. You no longer need to have the dreaded users table and hop around fixing security issues every day. That's the job of the identity provider now, so our developers can focus on their business functions. That's a relief to users too, who no longer need to register to countless websites and remember the passwords or share their passwords on each. They can sign into any website with their Google, Facebook, or any other famous account. Win-win for everyone. One thing to note before we move ahead is that the identity provider can still be an in-house system. It doesn't necessarily need to be a third party like Google or Facebook. This mode will just separate out user management out of your main website code. More on that later. We can now have a look at the login mechanism used by OIDC enabled websites in more detail, but I'm really in a fix now whether to go in detail about OIDC now or after the OAuth2 discussion, as the former is built on top of the later. As a solution, I'll keep the details at a higher level than they should be for now, but you will fully understand after the OAuth2 video later. Do remember for now that OAuth2 is an authorization server meant to allow access to protected resources and not an authentication server. But OIDC is able to leverage the authorization workflows to authenticate users during the same workflow. You don't need to fully understand everything, just bear with me for now. So the steps are, you navigate to the website or app using browser, and please remember that we'll stick with the technical term for those websites or apps called client. The client redirects your browser to the OAuth2 authorization server, which is acting as identity or OpenID provider here. It needs to send a bunch of stuff with the request, including its client ID, a redirect URL, a response type, and a scope of access list to request authorization for services. To add authentication to the workflows, the client adds a special scope to the list called OpenID. The authorization server checks client ID sent above in the list of registered client IDs to validate the client, and if necessary, prompts for a login where you, the user, needs to enter your username and password. Note the login form is from the authorization or identity server and not the client. The authorization server then presents you with a consent form based on scopes requested by the client. You grant or deny permissions to access. Having the OpenID scope means you are authorizing client to have access to basic identity information from the identity provider. The authorization server redirects back to client using the redirect URL sent in step 1, along with an authorization code. The code can be exchanged for access and/or an identity token. The client contacts the authorization server directly and securely sends its client ID, client secret, and authorization code. The authorization server verifies the data and responds with an access token, and if the server supports OIDC, an identity token, if the scope list had OpenID, of course, as one of the scopes. The client can now use the access token to send requests to resource server for APIs and services like Google Drive. Our focus right now is on the ID or identity token, which is considered a proof of authentication. It contains some info about user too, like name, email, etc. The authentication and authorization workflow is now complete. But what just happened here? The OpenID Connect leveraged a workflow meant to authorize access to protected APIs and resources, like say Google Drive from our previous example, to authenticate users in the same breath, essentially by asking you, the resource owner, to authorize client access to basic information about your identity. The authorization or identity server must support OIDC to issue the identity token though. One thing that would be clear in OAuth2 video later, but to emphasize now, is that ID token is just a proof of authentication. Your client cannot use it to access any resources anywhere with that. For that, you need access tokens. That is it for authentication and OIDC. In the next video, we focus on OAuth2 itself and concepts and workflows described above would make even more sense. If you like the content, please like and consider subscribing to be notified of exciting upcoming content on this channel. Thank you and goodbye.